Hey guys, it's Mrs. Spears. I'm getting ready to do the lesson for 12.5, which is line plots. This lesson takes a little bit of a detour. The last few lessons were on customary measurement and converting between different units with that. This is kind of its own thing. I'm not really sure why it's like smack dab in the middle of your chapter, but it is, so we're going to go ahead and do it today. I think you'll catch on to it. I'll show you kind of where some of this comes from back based on stuff that you learned in the past to help you make some connections first. So with line plots, they are like a special kind of graph. And so to kind of show you where they come from, I'll show you. I know it's kind of fuzzy because I'm looking at my computer screen. This is bar graph, which I know you guys know what that is. This is something you learned a long time ago. And it's just a visual representation of some data. It just shows like conclusions based on information that somebody has collected. So this graph is called What Kind of Pet Do You Own? And it's got rabbits, dogs, cats, goldfish, and hamsters. And on the side are the numbers that show how many people have each of those animals, and the bar graph compares. So, you would use this graph to say, okay, what animal does most people have? Cats. Okay, what animal does not a lot of people have? Rabbits. Which animal has more dogs or goldfish? You'd say dogs. So, you'd answer questions based on interpreting this graph. Now, a line plot is very, very similar to this kind of graph. So, let me show you. Oh, where did that go? Oh, here we go. Much better. That was what I was looking for. So this is a line plot, and it's basically a bar graph, except for it doesn't have numbers on the side, because the numbers on the side is something you would just count the pictures for. If you ever seen like a picture graph before, this is pretty much the same exact thing. So this is a similar graph to the one before. It says pets for each student, and then this measures how many pets. How many kids have 0 pets? How many kids have 1 pet? How many kids have 2 pets? 3, 4, 5, 6, all the way up. And how you would figure that out. So if I would say, how many kids only have 2 pets? You would look at the number of pets. 2 pets, that would be 1, 2, 3, 4, 5, 6, 7. 7 kids only have 2 pets. If I said, how many kids have no pets? You'd go down to 0. And 1, 2, 3, 4 kids have no pets. If I were to say, what's the highest number of pets any student has? You go to the highest number. Say 1 student has 6 pets. That's the highest number of pets. So this is basically just a bar graph, except for instead of using the side where the numbers were in the bar graph to count how many of each thing it is, this one just shows it with X's. So a lot of times with a line plot, it's not going to be words down at the long for each column at the bottom of the graph. It's going to be some kind of number. In your lesson today, it's actually fractions that are down there. So we're scraping off some of those fraction skills that we learned a couple weeks ago. Most of the stuff in the lesson today is not even find the fraction of. It's really just plotting your data. So, all of the examples in this kind of follow the same sort of pattern. So, after we do a couple, it should make more sense. Sorry about the shaky camera again today. I'm still waiting on my tripod from Amazon. It says it should be here Thursday, so a couple more days. All right, so the problem says, the data show the lengths of the buttons in Jen's collection. For an art project, she wants to know how many buttons are longer than 1 inch. So it looks like she went through all of her buttons and she measured them. Okay. So she would say, it looks like she measured them in inches. So I'm going to use the inches side. So this button would have been about 1/4 of an inch, 1/4 of an inch. Because if you look at the ruler, here's 1 inch. These big lines right here represent 1/4 of an inch. So that's 1/4 of an inch. 2/4 of an inch, which we also know that 2/4 is half, 3/4 of an inch, and then 1 whole inch. And then the smaller numbers in between, these medium-sized lines measure 1/8 of an inch, so 1/8, 2/8, 3/8, 4/8, all the way up. And then they divide each of those 8ths in half, which means each little tiny line is 16ths. So what she did, she went through and measured all of her buttons, and she made a list of all the different lengths that she found. So she had, looks like 1, 2, 3 buttons that were 1/4 of an inch long, one that was 3/4 of an inch, and 2 that were 4/4 of an inch, so 1 whole inch. So she just kind of made a list based on all of her data over here. So example 1 says, oh, sorry, I skipped a spot. You can use a line plot to solve the problem. A line plot is a graph that shows the frequency of data along a number line. Frequency is just a big fancy word that means how often do you see it. So this line plot actually helps us see, like this is the one we did earlier, helps us see how often something happens. So like, for example, if I said how many kids, how often does a kid have 2 pets? You would say, well, there was 1, 2, 3, 4, 5, 6, 7 kids that have them. So it kind of measures how often something occurs, or how many of each type of thing there is. Make a line plot to show the data. Step 1 says to order the data from least to greatest and complete the tally table. Well, they did that for you. You know how to do that. You take the smallest fraction. The smallest fraction was 1/4. So they put that one first. The next size fraction was 3/4, and then the third size fraction was 4/4. So then you can go through and make a tally chart. So I've got, for 1/4, I've got 1, 2, 3. 1, 2, 3. 3/4, I've got 1. And 4/4, I've got 2. So according to this chart, she's got 3 buttons that are 1/4 inch long, 1 button that's 3/4 of an inch long, and 2 buttons that are a full inch. Label the fraction lengths on the number line below, from the least value of the data to the greatest. So from smallest to biggest, just like a regular number line. It looks like they give you 4 spots here. I think all they did was they did 0, 1/4 of an inch, 2/4 of an inch, and 4. Oh, sorry, I messed up. Not sure why they gave you 4 spots, but that's okay. 3/4, because we don't have any 2/4 in our data, so we don't actually need to put it on here. You could also do it, I guess you could do it a little differently too. You could have done, let me rearrange these a little bit here. You could have done it this way too, where you've got broken down into 4 equal spots. And then you just wouldn't have any data on here, and that's fine. So let's see here. Plot an X above the number line for each data point. So we've got 4 for the 1/4. So I'm going to do 1, 2, 3. Do you have my 3 tally marks? I don't have any for 2/4, so I'm going to leave that one blank. 3/4, I've got 1. And 4/4, I've got 2. So that's our line plot. It says write a title for the line plot. So I'm going to say the title for this one is length of buttons. Oh, maybe you're supposed to write the title on this line down here. Oh, whatever, it's fine. You can write it here too. Let's see here. So blank buttons are longer than 1/4 of an inch. Well, we have 3 buttons that are exactly 1/4 of an inch. So all the buttons that we have, I'm going to cover that one up, that are larger than 1/4. We've got 3 X's and the other sizes all together. So that means that there are 3 buttons longer than 1/4. Because it would count these 3, which are, all 3 of these are longer than this one. How many buttons are in Jen's collection? We'll just add them all up together. We got 1, 2, 3, 4, 5, 6 buttons all together. And what's the difference in length between the longest button, which is 4/4, and the shortest button? Well, the difference between that one is you guys can figure this out because you know how to subtract fractions. 4/4 minus 1/4 equals 3/4. That's the difference in size. So that's how big from the biggest to the smallest. So line plots help us see data in different ways. It's just basically a way to organize collected data is all it is. You guys have done data and stuff with science. So this could be a way that you showed your data and your conclusions, or when you analyze your data, when you do the scientific method, that kind of thing. But this is just a way to organize information is all it is. So I'm over on page 666. And I'm doing example 2. Let me go turn the light on here 1 second. Okay. Much better. It was getting kind of dark in here. Okay. Some of the students in Miss Lee's class walked to school. The data show the distances these students walk. What distance do most students walk? So it's make a line plot to show the data, or the data from least to greatest distance. So here's all your data. So one student, distance to students walk to school in miles. One student walks a half a mile. Another student walks a half a mile, and so on and so on. So we do the same thing. We make a chart. You don't always have to make the chart unless if you want to skip straight to the line plot, you can. But the chart kind of helps you organize this a little bit further if you need to. Let's see here. Data from least to greatest. So we've got the smallest one is the 1/4. The next size is 1/2. And the biggest size is 3/4. So for 1/4, we've got 1 kid, 2 kids. So 2 kids for that. And then 1, 2, 3, 4. 4 half sizes. And 1 3/4. So then you take all of that information and you transfer it over here to your line plot. So I'm going to put 1/4, 1/2, and 3/4. I'll put my title down here this time because why not? Okay, and then we put our X's on our line plot. This is the fun part. So I've got 2 students that walk 1/4 of a mile to school, so I'm going to put 2 X's on 1/4 to represent those 2 students. 4 students walk a half a mile, so 1, 2, 3, 4, and 1 student walks 3/4 of a mile. So if it said most students walk, well, the biggest number represented would be in the half. So most of the students walk 1/2 of a mile to school. Now, if we were at school together, I would do a really fun thing where we could actually make our own line plots with our own class data instead of using some other class's data. But we are not at school right now, so this is kind of the best thing we can do right now. All right, number 3. So how many more students walk 1/2 mile than 1/4 of a mile to school? Let's see here. Well, 4 students walk a half mile and only 2 students walk 1/4. So how many more students would be a subtraction problem? We have 4 students that walk, I'm going to write half down here so you remember where that 4 came from. You don't have to do that, but that helps me see where I got the 4 from. 4 students walk a half a mile. And then 2 students walk 1/4 of a mile. So how many more students? 2 more students walk 1/2 mile. and 1/4 mile. There we go. What's the difference between the longest distance and the shortest distance? So again, finding the difference is a subtraction problem. So the longest distance is 3/4 of a mile. The shortest distance is 1/4. So we're going to subtract the longest distance minus the shortest distance to find the difference. And that's 2/4. What if a new student joins Miss Lee's class who walks 3/4 of a mile to school? How will the line plot change? Well, if they get a new student who walks in and that person walks 3/4 of a mile, all they'd have to do would be to add another student to that line, to that section. So our line plot would be different because we'd have a different total number. So we would have, instead of just having 1, 2, 3, 4, 5, 6, 7, we'd now have 8 kids. There would be the same number of kids in 3/4 as 1/4. So there would be a couple of different changes that would be made to it, but as far as changing the graph itself, all you'd have to do would be to add the other person to this. That's all you need to do. All right, over on page 667. So the food critic collected data on the length of time customers waited for their food. Well, that sounds like a long time to wait for food. Order the data from the least to greatest time. Make a tally table and a line plot to show the data. All right, so let's see here. So that one person waited half an hour for their food. One person waited 1/4 of an hour, which is 15 minutes. One person waited 3/4 of an hour. That's 45 minutes. 1/4, back to 15, half. 1 whole hour. This person waited a long time for their food. That was kind of mean. But I'm going to put those in order from least to greatest. So your brain should be like, oh, well, the 1/4 is the smallest because that would be one piece the size of a fourth. That'd be the smallest out of all of these. So that goes on here first. And then the next size up would be 1/2. 1/2 size piece. Next size up is 3/4. And the last size is 1 whole. Again, I feel sorry for that person. That was a long time to wait. Our title for this would be Time Customers Waited for Food. Let's see, for 1/4, we had 1, 2, 3. So we put 3 X's on that one. For 1/2, we've got 1, 2. Put 2 X's for that. 3/4, there's just one of those. And we had just one whole hour. So there's a line plot that represents how long customers had to wait for food. So it looks like the most often was 15 minutes, the 1/4 of an hour. So that's pretty good. That's not too bad. They just had a couple people who had to wait a really long time. So it says, use your line plot for 2 and 3. On how many customers did the food critic collect data? Well, this is asking for how many customers altogether were collected in the data. So you could have counted them from here all together. You could count them from here all together. So it's 1, 2, 3, 4, 5, 6, 7. 7 people were collected all together. What is the difference between the longest time and the shortest time customers waited? Well, the longest time is 1 hour. Shortest time is 1/4, which means the difference would be 3/4 of an hour. Again, if you're not sure how I got that, turn that 1 into 4/4, and then you can subtract. 4 minus 1 is 3. And then you keep your 4. Don't forget about that when you're going from a mixed number. I know this is just a whole number, not really a mixed number. But you'd have to use the same idea as you would it for a mixed number. And this one, I want you to pause the video here so that you can try this one on your own. Like I said, it says the ribbon length used to wrap packages. So make your tally chart over here using your data from this chart and then make your line plot. So I want you to pause the video right here. All right, here's your answer. So length, I'm going to go from smallest to biggest. Smallest length was 1/6. Next smallest length, these are all in sixths, so that's good. I don't have to look at different size pieces. That makes that better. 2/6 is my next size. Three sixths. No 4s. Oh, there's a 5. Oh, they gave you space for a 4, because it would have been 5, 6. Because there's only 6 on here. So if you want to fill in all the spaces, then you can put a 4, 6 in here. You just won't have any data for it since there's none in your chart. 5, 6, and 6, 6. Sorry for the wonky handwriting. I have to look through the camera to the paper and hope that I wrote it in the right spot. Okay, so we've got, how many 1/6 do we have? We have, well, just one of those. 2, 6, I've got 1, 2, 3 of those. 3, 6, I've got 1, 2. 5, 6, just one of those. And 1 6/6. So then you put your X's after that. Got 1 in the 1/6. 3 in the 2/6. 1, 2, 3. 2 of these guys. No 4/6. 1 5/6 and 1 6/6. Like I said, if you left this one out and you just had, you know, the 5/6, and that would have been fine with me. That makes sense. I think they just put that in there so you could see they did it so they could do it evenly. Oh, and your title, almost forgot, is ribbon length. Oh, jeez. Spelled that wrong. Okay. What's the difference in length between the longest ribbon and the shortest ribbon? Longest ribbon was 6, 6. Difference, subtract the shortest length, and the difference is 5, 6. All right. Turning the page, we go to 668. All right. So this one's a go deeper problem, which means this one's a little more challenging. So I'll probably just talk this one through with you. Line plot shows the distance students in Mr. Bourne's class ran at the track in miles. So 2 kids did 1/5 a mile, 2 kids are 2/5 a mile, 1 kid is 3/5, 2 kids are 4/5, and 1 kid did the whole mile. Altogether, the students run more or less than 5 miles. So, I guess, well, okay. So what he asked you, you're fine. Altogether, they run more or less than 5 miles. Okay, so we're asked to find, we're trying to figure out altogether how much, oops, sorry, did the class run. What information do you need to use? We need to use the line plot and the data, which is the information in the line plot. How will the line plot help you solve the problem? What's cool about this is the line plot can help us kind of see a big picture understanding of the data. It also helps us see how many kids ran each distance. So what operation would you use to solve the problem? You could mostly just use addition. So, what I would do, there's a couple different ways you could solve this problem. You could just do 1/5 plus 1/5 plus 2/5 plus 2/5 plus 3/5 plus 4/5 plus 4/5 plus 5/5. You could do all of that and then put your answer over 5. And that would be how much they ran and figure it out from there. What I like to do is I'm going to actually do this step over here in this empty space over here. I'm just going to figure out how many's in each altogether and then add them together so I don't have as many to keep track of. So if this student ran 1/5 and this student ran 1/5, altogether this group ran 2/5 of a mile. This student ran 2/5, this student ran 2/5, all together, that would be 4/5. Then just 1 3/5. 4/5 plus 4/5, because both of these are 4/5, be 8/5 and 5/5. So if we add all of those up, we have 2, 3, 4, 5, 6, 7, 8, 9, 17, 22. I get it right. 22/5. So we got an improper fraction. We can't use that. We know that. So we got to divide. 5 goes into 22 4 times. Ooh, there we go. That'll be 20. Remainder 2, which means we have 4 whole miles and 2/5 of another mile. Okay, so as a class, they ran, you added up each person's distance. They ran 4 miles with 4 and 2/5 of a mile. Sorry. So we can write that in here. Students ran a total of 4 and 2/5. The distance is less than 5 miles. If they had 3/5 of another mile, if they had another kid run 3/5 of a mile or higher, they would have made it for sure. Altogether, the students ran less than 5 miles. So that one combined what we know about adding fractions as well as line plots. So there's a lot involved in that problem. I'm not going to go over these 2 problems with you. If you would like to do these as challenge for yourself, go for it. They work really similar to these ones up here. I just like to keep your videos at 30 minutes so I don't give you really long lessons. But yeah, line plots are kind of their own special thing. So they kind of threw them in there with you so you can use the units that you've been learning about. But for the most part, there's a lot of fractions and stuff in there too. So combines a lot of different things in it. If you've got any more questions about it, leave me a comment down below and I will do my best to answer them. Thank you for liking, commenting, and subscribing. I've always wanted to say that. But you don't have to do any of those things. But if you do any questions, I will be answering the comments, okay? So make sure you let me know if you need anything. All right, love you guys. I'll see you later. Bye.